Amanda's going to give us an quick overview, and then Marlene and I are going to talk about our work on H5 detection in wastewater. So we'll go ahead and get going on that now. So thanks, Amanda.
Hi, everyone. So just a reminder, WastewaterSCAN is a national effort based out of Stanford to build a national network. We have Allie at Stanford and Marlene at Emory. Our scaling partners are Verily and the National League of Cities, and all of our partners are you on this call and our wastewater and public health officials. Next. So we're just going to give a quick overview of where we're at currently. So we have 191 sites in the program. This represents 13.5% of the US population. 40 states are covered, including DC. Next. Currently, we are monitoring SARS-CoV-2, influenza A, influenza B, RSV, human metapneumovirus, and EVD68, human parainfluenza, and then 2 enteric pathogens, rotavirus and neurovirus. And lastly, we are looking at Cioris, Hep A, and Mpox. And we are going to just provide a brief overview, a couple of slides from now, of what the current categories are. But when we send the PDF out after the meeting, there's going to be a more complete breakdown of all the stats and where we're at for each of these pathogens. Next. So we want to give a quick overview of the next phase. So as you know, we sent out a questionnaire to respond about your interest in participating in this next phase of the project. And 96% of you said that you were interested in continuing. So that's great. This next phase would be starting July 1st of this year, going to June 30th of 2025. We are still finalizing the selection of sites to continue on to this next phase, and we're hoping to send an email out to all of you next week with next steps. So we will get into that next week. Just as a reminder, all of our protocols and publications are open access. We show this slide at every meeting. Here are the QR codes if you want quick, easy access to our protocols and our preprints for the 12 pathogens we monitor. Next. Quick update on some new papers that we have. So as Allie mentioned, her and Marlene are going to be going over the H5 preprint that was submitted a couple of weeks ago. But here is the link to that if you want to see that. And Stephen, if you could put these links in the chat, that would be great. Next up, we have a new paper from Lara at Stanford, and this is on the solid liquid partitioning of dengue, West Nile virus, Zika, Hep A, influenza A, and SARS-CoV-2. And lastly, we sent an email about this, I believe last week. We have a new page on our website that kind of goes over the all of the papers that have been put out as a part of this project. So all of the peer-reviewed papers that have been done. Next slide. So when you are on the main page of the website, on that left navigational bar, you'll see this essentially little paper icon. If you click on that, that's going to take you to this page. And this is very similar layout to what the About page is. And it provides an overview of all the papers that have been written, organized by topic and theme. And under each paper, there is a quick synopsis. So analysis, key findings, and public health takeaways. So this will provide you with quick idea of what the paper is about. If you want to learn more, you click the link and that'll open to a public free access publication of the paper. Next. And here's just a quick demo of where you can find it on the site. So like I said, it's on the left-hand navigational bar. You click publications, and it'll open. On the right-hand side of the screen is where the contents are. So you can either scroll down to these sections or click them. And so this provides a narrative of all the projects that WastewaterSCAN has kind of focused on, looking at pre-analytical methods, looking at correlations between wastewater concentrations and clinical data. And as I said, each of these has kind of a quick summary of what the paper is about. And so I believe, yep. So if you click the link, it's going to take you to the open access publication. And so We hope that this is a valuable resource to you all. We think it is pretty thorough in covering the broad scope of items we've looked at as a part of WastewaterSCAN. And now I think we're going to do a quick overview of the wastewater categories on the next slide. So we are just going to provide high-level summary right now for the national wastewater categories. We will, like I said, send out a PDF with more details on the state, regional, and national categories. But currently, SARS-CoV-2 is in the low wastewater category. We're currently seeing similar levels to where we were this time last year, and most sites are currently in that low wastewater category. Influenza A is still in the high wastewater category. Even though there has not been a trend in the last 21 days, concentrations are still rather high, and we're seeing a much longer tail in concentrations decreasing compared to this time last year. Influenza B and RSV are both not in a seasonal wastewater onset anymore. Most sites are in the low wastewater category as a result. Human metapneumovirus is in the high wastewater category due to high concentrations. Currently, 100% of samples are having positive detections for human metapneumovirus. Parainfluenza is in the high category due to an upward trend in high concentrations. EVD 68 is in a low category due to few positive detections. Currently, there's been 17% detection rate in the last 10 days. Next, we have neurovirus and rotavirus. Both are in the high category due to high concentrations, and both have 100% detection rate in the samples we are seeing. And lastly, we have Mpox, C. auris, and Hep A. All are in the low categories due to few positive detections. Mpox, there's been 1 positive detection in the last 10 days. C. auris, there's been 4 positive detections in the last 10 days. And Hep A, there is a 14% detection rate in the last 10 days. So that's a quick summary. We will provide more details in the PDF we send out after the meeting. Hand it over to Marlene and Allie.
Okay, thanks, Amanda. And please do check out that resource on the website. Amanda's put a ton of work into making that, and it's beautiful and has pretty much all the answers. If you have any questions or you want to dig in to the academic work that we've published. So thank you, Amanda, for sharing that. And we're super excited to have it on the site now. I'm going to talk a little bit about H5 influenza detection in municipal wastewater. As I think many of you have probably seen, we released a preprint last week describing some H5 testing at a few WastewaterSCAN sites that we've been working closely with. So we want to share a little bit more about that with you and answer any of your questions, etc. So for this work, we, along with Verily, designed and validated an assay for H5 specifically. So as you know, as part of our usual testing, we measure influenza A, and that influenza A assay targets the M gene, and it should pick up pretty much all circulating influenza A virus. And that includes H5 viruses, which are influenza A viruses, including the current clade of highly pathogenic avian influenza that's circulating among cattle. So that assay is described here. This is the overall IAV M gene assay. It's from CDC, and here's all the details. So that's what we're usually running on all of our samples and where the data that is publicly posted on the website comes from. This new assay is an H5 specific assay. So it targets the HA region of the genome, and it's designed to be specific to H5 based on a lot of sequences going back many years. And then we've also confirmed that it is a perfect match to 90% of all circulating H5 in 2023 to 2024. So that means that it should pick up 90% of the sequences that are out there, and it is highly specific to H5. The H5 assay will detect this circulating HPAI clade right now. It can also include other H5s, but it is very specific to H5. We tested the assay for specificity in silico and in vitro. And so this is the list of viruses that we tested against in vitro in order to make sure that not only were the sequences very specific that we were targeting with that assay, but also that the performance was very specific. And again, we expected to detect 90% of the H5 influenza strains. This is just a plot to show you that specificity. So you can see that this is a digital PCR output, and these positive droplets are in blue, and then negative droplets are in gray. And each one of these columns represents one of those different viruses that we tested against for specificity. This right here is our H5 positive controls. So you can see that there are a lot of positive droplets. It performed really well, and that we're not seeing positivity in all of the other samples that we screened against for specificity. So we have a lot of confidence that the assay is indeed detecting what we intend for it to detect. So we applied that assay to several sites around the country. There are 3 of these that are described in the preprint. So these two right here, the North and South utilities in Amarillo, which is in Potter and Randall counties in Texas, and then this site, which is in Dallas County in Texas. So these 3 are described in that preprint. We've since worked with colleagues in a few other locations to do some further testing. All of the extraction, positive and negative controls came out as expected. And what you'll see on all of these plots is on the x-axis, we have time. So we're going from the beginning of February to the middle of April in these plots. And then on the y-axis, we have the concentration of the targets in gene copies per gram of wastewater solids. The green triangles are the influenza A M gene. So again, that assay that we have been running for a long time now that captures all of our influenza A that's circulating. And then the pink circles are the H5 specific target. The empty circles or triangles represent a non-detect, and filled in represents detection. And then you can see the plotted concentration. So overall, what you can see is that the first detection that we had in this retrospective testing, so again, we looked at this, we did this testing in April, right, looking back at some of these biobank samples, was on February 25th in one of the Amarillo sites. And after that, we've had relatively consistent detection at the sites in Amarillo. We see a similar pattern in Dallas with no detection, although some background detection of influenza A, and then increased detection of H5. Sorry. So those 3 are the ones that are described in the preprint. And then we have also done some testing in Forsyth County in North Carolina. So again, you can see non-detect from H5 from the beginning of February until this first week of April, when we start to see some of those detections of H5. And then in Honolulu, Hawaii, and in Gilroy, California, we tested for H5, and all of the samples were non-detect. And so what you can see here is that there is influenza A detection overall, but we are not seeing any H5 associated with that. At the sites in Texas and North Carolina, you'll see that the concentration of H5 is very similar in many cases to the total concentration of influenza A, which suggests to us that that H5 associated influenza is probably the majority of the influenza that we're measuring, because those concentrations are so similar. In terms of timeline, you can see that, again, that first detection in Amarillo was February 25th. It was actually the beginning of March when there was the first reports of unspecified cattle illness in Texas. And then it was March 25th when those outbreaks were actually confirmed to be H5N1 in cattle. So we had early detection of H5 in wastewater compared to information that was available during that time from testing cattle herds. One final thing I want to note about this data, although I'm sure there are many more questions to talk about, is that what we've seen in Gilroy was an increase in influenza concentrations recently. And so that's what, that's what made us want to test in Gilroy, and why we tested there was that there was this recent increase in overall influenza A concentrations. But what you can see is that there was not an association with that increase in overall influenza A concentrations with H5. So I think this is an important piece of information that suggests to us that while looking at overall influenza A concentrations, since we know they're inclusive of H5, can be useful, it does not necessarily mean that those concentrations are driven by H5 or an animal-associated outbreak. So we want to be cautious in our interpretation of some of those increases, which you may see if you look at the publicly available data on our website. In Honolulu, we would not expect to be seeing any H5. There is no HPAI in Hawaii, and so it's great to see that in this place where we expected not to have any detection, we didn't have any detection. So I think the last thing I'll say right here is that, we do hypothesize that a lot of this is driven by milk that is maybe being discharged, or milk byproducts that are being discharged into the utilities. So all of these utilities have dairy operations associated in the area. We can't tell from this testing what the source of H5 in the sewer system is. The fact that we have cattle-associated outbreaks of HPAI right now means that the situation is quite different in terms of what animal inputs that may have H5 influenza are that are ending up in the sewer systems, because we know that milk is part of the food chain, and dairy processing plants are part of the food chain, and often in areas with municipal sewer systems. So it's much more likely that we're going to have contribution from cows, for example, than we are from birds and agricultural operations. So it's important for us to better understand what those inputs are, and acknowledge the limitations of what we can determine from this data. However, this does represent information that is an early warning of H5 in several locations, and also is really important for us to understand as we try to determine when we have changes in the overall influenza A signal, are those driven by more likely human-associated influenzas or animal-associated influenzas?
Okay, so, oh, sorry.
Oh, I just described this whole timeline on the previous page while we were looking at the data. And this is just describing what I just talked about in terms of kind of the early detection comparative to when there was the actual outbreak identified in Texas. And then it was April 9th that the herds were identified in North Carolina, and our first detections were earlier that week in North Carolina. So I already talked through this, but you'll have the slides. You can refer back to them later.
Hi. Okay, so what we really would like to get your input on today is on this slide, and this is our last formal slide, and then we hope you guys will ask lots of questions and provide comments. So we are considering potentially scaling this H5 assay in prospective measurements across the WastewaterSCAN sites. So far, our work has been retrospective with biobank samples with partners who have been eager to engage. But we've noted, so, with that work, we've sort of set the foundational science. We've created a preprint. It's been peer reviewed. We actually have reviewer comments to respond to. They were minor comments. So we hope to have that completed and back to the journal by the end of the weekend, and probably a paper, hopefully fingers crossed, accepted early next week. So we feel like the science we've done is solid to set the framework for this, or the foundation for this. And we've also been getting an overwhelming number of requests from some of you to provide data on H5 in wastewater. So it's getting a little complicated to do retrospective analyses for everybody who is reaching out to ask. And I think the motivation that we've heard from people reaching out to us, on the one hand, is that, they would like to have negative results to just provide some reassurance that maybe apparent increases in influenza A are not associated with some H5 in the sanitary sewers. For instance, in Gilroy, we were I was pretty certain, because it's a more rural wastewater treatment plant, that we would detect H5, but we didn't. And that gave a lot of reassurance to the local health department, you know, that this was actually probably not associated with H5 in the sanitary sewer system. And in fact, as I put in the chat, there was some data suggesting that there actually was a slight increase in influenza A cases in humans, not, of course, H5N1, but just regular influenza. Also, positive results can help improve our understanding of the extent of H5N1 prevalence in the nation. And this is obviously something that's super important to public health. And the currently is sort of like the biggest concern in infectious disease is better understanding where this virus is, you know, trying to understand if it's associated with animals in certain areas and how to sort of, you know, respond to it. And those are local actions that local partners would take. So that has been the motivation in people reaching out to us. So if we did scale this, it would be prospective and it would be included in every sample that's being processed. So, you know, if we were to do this, we would be developing a FAQ sheet, and some of the questions that we would include in the FAQ with answers are shown here on the right side of your screen. You know, influenza A is going up. Does that mean H5 is present? What does it mean if we detect H5? What can it mean? What can it not mean? What can we conclude from it? What are the caveats in interpreting a positive result? What should we do if we detect H5? We can put some suggestions there. You know, H5 is a select agent. Is that a problem for the program? The short answer is no, but we want to explain that. Are there any safety concerns for operators? WEF has already put out a statement on this, I think, so we would just sort of direct people to that. Can you tell where H5 is coming from? There's already been a question in the chat today about that. And the answer in short is no, but we have some suspicions and evidence to suggest that, you know, dairy processing plants who have permits to discharge into the sanitary sewer can serve as a source. Steve, we're not quite ready for questions yet, but you'll be the first to be able to ask a question. The other thing that we're thinking through is how would we share this H5 data? Possibilities would include like a private dashboard, a staged dashboard. It's not really private, but it's not the data.wastewaterscan.org website, but it would be a staged version of that website that would just have access to the H5 data. So you would need that link to get in. And then it would also, if we did this, it would also require that many of the public health partners engaged in this project would have to reach out to wastewater treatment plants to work together to understand various inputs to the sewer system. And that's actually very useful beyond this project itself, like with H5, and that sort of engagement between public health and wastewater treatment plants will just strengthen, I think, the use of wastewater-based epidemiology going forward. So that's a positive. And then if we do scale H5, we would have to probably temporarily sunset another assay that we're running. So we were thinking about sunsetting RSV since RSV season is over. We heard from some partners that that was not ideal because they're using the RSV data and rely on it and don't want that data source to disappear. So we're thinking about that. So we're interested to hear your thoughts. Sort of a complicating factor here is that the window for action is now. And if we're going to pivot, we need to do it quickly. So this isn't something that we can wait 4 weeks to decide if we're going to do. So Steve, you have your hand up. Would you like to ask a question?
Actually, it was a comment because you said you were looking for feedback. There's been a lot of concern in the news and concern raised by CDC that the dairy workers and the farm owners have not been overly cooperative with having people tested. And so, obviously to the extent that you can reach your program into areas where those dairy workers might be, that I think will be a huge benefit for public health at understanding what's going on with this in terms of the risk for humans at this point.
Yeah, thank you for that, Steve. That's a great point. And it is hard for us to the way that we process the samples in the lab and everything, logistically, it's complicated to separate samples into ones that are potentially have, dairy plant workers and those that don't. So for us, logistically, it's just way simpler to scale this nationally and do that. But that's a great point that we can't discern whether the H5 we're detecting in the wastewater is from animals or humans. I mean, we suspect that dairy is a source, but human infections could also contribute to the wastewater, and we just can't rule that out. And I think some public health departments might be interested in doing more human testing just to better understand, especially if they're seeing H5 in the wastewater. And that information, whether it's all negative or not, I think is still super informative to understand the epidemiology of this disease.
There's a question in the chat. Will state health departments be notified if we're planning to expand this H5 testing to other sites? Yes, so we're having this conversation with all of you right now, but we have our full list of public health contacts that are associated with all of the sites in the program. So, following this conversation, we'll be doing further outreach and sharing of information, including the facts that Allie described, to make sure that we're in touch as much as we possibly can be about this addition. And if there are, I think maybe Amanda, you could drop our email in the chat if there are others who we want to make sure are added to our lists, then, please let us know, because we always want to make sure we're reaching everybody.
And just to let you all know, we are in close contact with a number of federal agencies, including CDC, HHS, OPPR, and NIAID, about our work, and have received, had the opportunity to present to them and have received positive feedback from everybody. We also want to acknowledge our amazing partners in North Carolina, Hawaii, Santa Clara County, Dallas, Amarillo, who have been just amazing to work with. And it's been a lot of, I don't want to say fun, but it's been fun working so closely with them and seeing how how willing they are to engage in this disruptive technology and use it internally. It's been really great working with them, and we couldn't have done this without them. John, did you have a comment or question?
Just a question, really. So you guys have done a really good job modeling, I feel like, when we're seeing different stages of an increase or a decrease, for that matter. And it seems like from your preprint, the increase that you guys detected perhaps from these dairy plants was pretty rapid, not what we would expect from just normal disease transmission in a population. It was perhaps a big influx from dumping of this material. So I'm wondering if you guys could use some statistical method to say, okay, this is not what you would expect from disease transmission in a community. This is probably from some event where a large amount of agricultural waste was discharged, versus what we might see, a much smaller and more, slow increase.
Yeah, that's a good question. I think that it's true that particularly the 3 sites that we report in the preprint are ones where we saw these very, very unusually high levels and a very quick increase. I think that is absolutely potentially indicative of inputs that are a little bit different than what we're typically seeing as influenza-related inputs into sewer systems. But two things, I guess, that complicate that. One, I think it's important to clarify that we don't expect or suspect necessarily that there's dumping of milk from infected cattle or known infected herds into sewer systems. I'm not ruling that out. Obviously, I'm sure that could happen, but what we're seeing consistently is that these areas have dairy industry that are permitted dischargers into the wastewater utility systems. And I'm happy for any of our colleagues from Texas who are on the call who want to say more about that, to say a little bit. But those are, expected inputs into the sewer as part of normal operations. And the thing that is so strange and different now is that because dairy cattle are sort of the primary population of the current outbreak, those inputs that are part of normal operating, entering sewer systems are more likely to contain H5 than they previously would have been, right? So we're not expecting that there's necessarily any activities happening that are not as sort of they should be. And then the other piece of that is that, yes, we did see this sort of pretty anomalous, I guess, spikes in these 3 locations, but we don't have great information characterizing the inputs into all of the different sewer systems as part of WastewaterSCAN. So that's why I have this note on here that I think, working together to better understand a lot of those inputs will help us know whether how to interpret the data better. And, it may be that there are very significant spikes like the ones we've seen in areas that have a lot of activities from dairies. But then there may be other areas that have more limited inputs to sewer systems from those sources. And so we may not see such anomalous levels, but could still have some input of material from, any species that have H5 that would show up in the sewer system. So I think it could be useful what you're describing, but the specificity of the testing for H5 is helpful because we don't understand, I think, the dynamics well enough to be able to say with a lack of specificity in influenza A testing, that's a new input, that's a different kind of input that must be associated with H5N1.
We're at time now, so we're going to go ahead and end, but thank you, John, for that great question. Please send a note to us if you have any thoughts or comments on our presentation, and we will be sending out the recording, which you can share with colleagues. So thank you.